So here we are, Elementary Algebra, Lesson 8.2, and this will be the first video. I'm sure there'll be a couple. This is Simplified Form and Properties of Radicals. Now, I already showed you in a lesson before how to do this, just kind of briefly, got your feet a little bit wet on how to do this. So now we're into it full on, and going to kind of go over it again. So hopefully what we did in the past might have giving you a little bit of confidence as far as understanding what's going on. So when we have a radical like that, it's not a perfect square. There are not two numbers multiplied together, or there's not a number multiplied by itself that's going to give me 20. So if you remember right, I said the first thing you want to do is try and see. Now this doesn't always work. Well, I mean, it does always work, but there are other methods when you get into some harder radicals. But for what we're doing now, it's a method that you should always at least learn and know, so that when you have easy numbers like this, it's easy to find the answer. So what you do is you look at two numbers multiplied together that give you 20, where one of those numbers you can take the square root of, if possible. And in this one we have 4 times 5. Now I picked that instead of 10 times 2 because 4 I can take the square root of. So I'm trying to find two numbers where one of them I can take the square root of. So then I take the square root of 4 and get 2. I can't do anything with the 5, so it stays under the radical sign. And there is the simplified version of the square root of 20. It's that easy. All right, let's look at the square root of 75, which is example 2. So there are several different numbers. 5 times 15 will give me the square root of 75, but I can't take the square root of 5 or the square root of 15. But I also know that 25 times 3 is 75, and I can take the square root of 25 is 5. Can't do anything with the 3, so it stays where it is. And these are the simplified versions of the square root of 75. You don't ever want to leave your answer like that if it can be simplified to that. It's kind of like leaving a fraction 2 over 4 and not writing it as 1/2. That is the actual answer you want, although that is correct. But this just means that you didn't do the work to come to that point. You always want to impress those that are looking at your math that you're catching on to what's going on. All right, so example 3 is the square root of 25x cubed. Okay, so this is very similar to some that we've done earlier as well. So aren't you glad we did these? Now I do this so much different than the book does. So if you want to read what the book does for example 3 and try that, that is fine. But gosh, I just think that my way is so much easier. But then again, that's just because it's my way. All right, but either way, whether you like the book way or you like my way, I'm just going to teach you my way, so I guess you're kind of stuck with that. But first of all, we just look at the numbers. Okay, 25. Square root of 25 is 5. Then remember we put our index there. It's always, if it's not there, it's a 2. You know, if it's a number other than 2, they'll put it in there. So how many 2's are there in 3? There's 1. How many are left over? There's 1 left over. Okay, so there 2 goes into 3 one time with 1 left over, and the 1 left over, the remainder, always stays in the radical sign. So we get 5x square root of x for the answer. And that's what the book got, but the book just took a lot more steps to get there, and I think what they do is kind of confusing. So anyway, example 4, 18 y to the 4th power. Nothing is there as far as an index, so let's put a 2. All right, so let's look at our number, 18. So what two numbers, all right, can I take the square root of 18? No. So what two numbers multiplied together give me 18, where one of them I can take the square root of? Okay, so I'm just going to rewrite it that way, as 9 times 2 instead of 18. Square root of 9 is 3, so that comes out, and the 2 stays in. Okay, now let's deal with this 4 here. How many times does 2 go into 4? Twice. How many is left over? Nothing. So there's no y's left under the radical sign. Okay, and we're done. Okay, so that's the simplified way to simplify these. Let's go to example 5. Now they start out with 3 square root of 32. Alright, so what we're going to do is we're just going to let that 3 kind of follow us along. Any numbers outside of the radical sign have already been simplified. Okay, part of simplifying is getting numbers out of the radical sign. So if you have a number out of there, you just kind of ignore it and just focus on the radical sign and then deal with the numbers outside if there's more than one. Okay, so right now there's just a 3. So let's just kind of let that follow along. We're going to change 32 to 2 numbers multiplied together that give me 32. Well, I've got 8 and 4. I've got, what else? 16 and 2. Anything else? I think that's about it. So, look at these. That one, I've got a number where I can take the square root of. This one, I have a number I can take the square root of. So it doesn't really matter which one you use. I prefer, and I'm not going to go into all the details about why I prefer this, but I prefer finding one like, if I can take the square root of 16, I like it when the 2 numbers that I take, one I can take the square root of, and the other one is a prime number. That works the best. Because what happens here is, yeah, I can take the square root of 4, but 8 also reduces to 4 times 2, and I can take the square root of the 4 in there too. So it ends up being kind of messy. So what I propose you do, find 2 numbers multiplied together, one of them you take the square root of, and the other one being prime. That's the perfect scenario. So let's go ahead and put 16 times 2 in there, because that's just what 32 is 16 times 2. And I'm going to take the square root of that 16. And it ends up being a 4. And I put a multiplication sign there because anytime I pull something out, all the numbers that I pull out are multiplied, so 3 times 4. And I'm left with a 2 there. So what is 3 times 4? 12. And that is my simplified version of that there. So this is example number 6, and this one's going to give us not really any more trouble, but this key right there is the source of much conflict when students are doing these, because they don't remember that there's a 3 here, and they're looking for 2 numbers multiplied together, give them 24 and all of that. Well, that 3 means that we're looking for a number multiplied by itself 3 times that gives us 24. So 2 times 2 times 2 is 8, so that doesn't work. 3 times 3 times 3 is 27, so that doesn't work. So 24 is in between 8 and 27, so it's got to be a number to multiply by itself 3 times to give us 24. It has to be a number between 2 and 3, and there aren't any. So what the heck do we do here? Alright, so what we're going to do is I'm going to start over there. So what we're going to do is we're going to try to, again, simplify this. So let's look at the numbers that we have that multiplied together will give us 24. So what do we have? 6 times 4. We have 8 times 3. 12 times 2. Okay, so stay focused with me here, because this is where it can get a little confusing. I'll try not to let it get that way. But when we had, let's kind of take a break here. When we had something like the square root of 20, what did we do? We tried to find 2 numbers multiplied together that give me 20 that I could take the square root of one of them. So I used 4 times 5 because I could take the square root of 4. The same thing is the case over here. I'm trying to find 2 numbers multiplied together, but instead of trying to find one number like here that I could take the square root of it, I'm trying to find a number over here that I can take the cubed root of it. Which of these numbers can I multiply, or which of these numbers can I multiply a number by 3 times in order to get one of these numbers? Okay, so I'm just going to tell you it's 8, because I can go 2 times 2 times 2 and get 8. And then 8 times 3 is 24. So 8 is the number where I can find a cubed root of. I can't with the 12 or the 2, can't with the 6 or the 4. Okay, so that index of 3 is very, very important. It tells you that you're looking for two numbers multiplied together that give you 24, and one of those numbers you have to be able to take the cubed root of it. So 8 times 3 is what I'm looking for. So that being the case, let's go ahead and instead of write the cubed root of 24x cubed, let's write it as the cubed root of 8 times 3x cubed. So I just wrote it as 8 times 3 instead of as 24 is all I did with that. So here we go. What is the cubed root of 8? Well, we said it's 2. 2 times 2 times 2 gives me 8. So I pull that 2 out, okay, and that goes away. Found the cubed root of that. Do I know a cubed root of 3? No, I don't. So I leave it as that 3 stays in there. If I can't pull it out, it obviously stays in there. How many times does 3 go into 3? Once. Is there anything left over? No. I'm done. Okay? So, let that kind of soak for a little bit, because that's kind of some pretty hard stuff. In fact, I'm going to go to the lesson and do an example of some of these, just of a cubed root, just so you have a little bit of experience doing those. So I'm going to jump to, well, in fact, I'm going to do 81C. That looks like a monster, so let's go ahead and do that one. Okay, so there we go. 81C. Let's go ahead and do this. So, fourth root, we're trying to find two numbers multiplied together that give me 32, and one of those numbers can I take the fourth root of? So if I have 16 times 2, that gives me my 32. Can I take the fourth root of one of those? 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the fourth power is 16. So, because those are the same, then that works. So what I have here is 2 times 2 times 2 times 2 times this 2. Gives me my 32. Okay, so what I'm going to do, I'm going to show you another trick here. Sorry, I'm probably giving you so many tricks you're getting confused. This can be written as 2 to the 5th power, right? So 32 can be written as 2 to the 5th power, x to the 10th, y to the 5th, with an index of 4. Now, watch what happens here. How many times does 4 go into 5? One time. Oops. With how many left over? One left over. So the one left over stays there. So 4 goes into 5 one time with one left over. How many times does 4 go into 10? Twice with 2 left over. How many times does 4 go into 5? Once with 1 left over. And you're done. You did not really even have to do much thinking there to get that long, complicated looking answer. It's just a matter of taking the number, and in this case the number part is the hardest part, isn't it? You have to write it as all kinds of different stuff in order to get it out of the radical, but the letters are just easy. How many times does this go into each of the exponents? And that's it. Alright, so I am going to continue on with this lesson. In fact, we're going to go back and start with the quotient property in the next video, which will be 8.2b.